So today's lesson is, like I said, I'm going to keep it short and sweet. Hopefully around 5 to 10-ish minutes, but I promise you nothing more than 10. Okay, I'll even keep the recording up there so I make sure. What we're going to talk about today, it's a little weird, but it actually really comes in handy. What we're going to talk about are imaginary numbers. Okay, and I remember when I first learned about this, I was like, imaginary numbers, okay, so some person just made up a bunch of numbers that were not real. And that actually is what somebody did, okay? Remember, before when we were talking about taking the square root of something, if we ever had a negative under a square root, we always said that we got something that wasn't real. So some guy, I don't know who it was, said, well, that's kind of silly. That one little negative sign shouldn't be making us stop working whatever we're working on. So they created imaginary numbers, which deals with these problems where you're going through, you get this negative under the square root, and you get something that's not real. So imaginary numbers work when we have a negative under a square root. Specifically, we say that I, which stands for imaginary number, is equal to the square root of -1. So now, anytime we have the square root of a negative, instead of just saying, oh, it's not real, instead we can talk about it in the sense of the imaginary numbers. Okay? Let's do an example, and hopefully that makes it a little more clear. So what if I gave you the square root of -16? In the past, we would have said, oh, there's a negative under there, it's an even index, we can't do it. But now what we can do is, really, if we think about it, isn't the square root of -16 really the square root of 16 times -1? Right, because -16 is just 16 times -1. And I can break this up because this is really the square root of 16 times the square root of -1. And now the square root of 16 will ask just 4, and the square root of a negative, it's not real, so I'll say that it's an imaginary. So our final answer, the square root of -16, is going to be 4i. Okay, I represents, or I is the square root of -1. Okay? We would do the same thing if we had the square root of -25. This is really the square root of 25 times the square root of -1, which is going to give me 5i. Okay, so now instead of saying no real answer, you give me the imaginary answer. And this would work the same way if we had something that wasn't a perfect square, or a perfect radicand. For example, if I gave you negative the square root of 12. Okay, we can take the square root of 12 because we get 4 and 3, and you break that down. I've got my pair of 2, so that would be 2 times the square root of 3 left inside. But because I had this -1 chilling on the inside, I'm going to pull that out, and I'm going to be left with I. So your final answer is 2i times the square root of 3. So anytime you have a negative under a square root, you can always pull out an I. There's just one more thing about i's. Okay, and like I said, when we introduced this, we said that the square root of -1, you can't really simplify that, so we're just going to call that I. Okay, or we could say that this is what I to the first power is equal to. Okay, so I'm going to say that I to the first power, well, that's just I. Okay, and it is kind of normal to write i's with the little, tail on it. Okay, now what if I do I squared? Okay, well, I squared is I times I, which is the square root of -1 times the square root of -1. Or we can really say that this is the square root of -1 squared. And a square and a square root undo each other, so this is just negative 1. Alright, I'm going to write this over here in a different color. So I to the first power was I. And we just figured out that I squared was equal to negative 1. Let's figure out I cubed. Okay, well I cubed is just going to be I times I times I. So that's going to be the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Okay? Or, actually, quick and easy way, couldn't we say that I cubed is I to the first times I squared, since I already know what those things are? Because I to the first is right here. That's just I. And I squared, we just found out, is right here. So what's I times negative 1? Well, that's just negative 1I. Alright, so I'm going to write that over here. I cubed, we figured out, was negative I. Okay, now let's figure out I to the fourth. Well, isn't I to the fourth just going to be I to the first times I to the third? Well, I to the first is just I, and I to the third is negative I. Okay, well, this is going to give me negative I squared, because I have I times I, that's I squared. But I already know I squared, that's negative 1. So this is negative 1, which is just 1. So looking at I to the first, second, third, and fourth, we get I, negative 1, negative I, 1. Okay, now I'm going to extend my page a little bit, and we're going to do I to the fifth. I'll do that in blue. So I've got I to the fifth. And isn't I to the fifth just going to be I to the first times I to the fourth? And I to the first was I. Whoops. And I to the fourth was 1. So I times 1, that's I. So I to the fifth gave me I. Okay, so now let's do I to the sixth. Well, I to the sixth is going to be I to the first times I to the fifth. And I to the first was just I, and I to the fifth I just found out was I. So this gives me I squared, but I already found out I squared, that was negative 1. So I to the sixth was equal to negative 1. Let's do I to the seventh. Well, I to the seventh is going to be I to the first times I to the sixth. I to the first was I. I to the sixth I just found out was negative 1. So I times negative 1, that gives me negative I. Now let's do I to the eighth. Well, I to the eighth is just going to be I to the 1 times I to the 7th. I to the 1 was I to the 7th we just found out was negative I. So here I get negative I squared. But I know from the first round that I did this, I squared was negative 1. So this is going to give me negative 1, which is just 1. Alright, let's take a minute and look at this. When I did, let me get my highlighter. When I did I to the first, I got the same thing as when I did I to the fifth. When I did I squared, I got the same thing as I to the sixth. I to the third gave me the same thing as I to the seventh. And I to the fourth gave me the same thing as I to the first. This is going to happen every single time. We're going to keep going through these 4 values. Okay, so the way that I remember it is for i's, it goes, ready, this is fun, it goes, I won, and the middles are negative. Okay, so we can always remember the first 4 exponents of I, because it goes, I won, but the middles are negative. So we can use that. All right, I'm sorry, I'm over 10 minutes. We can use that because if I ask you I to the 7th, okay, we know that if it goes through these 4 cycles, or if it goes through the first 4, I'm going to repeat myself, right? So let's see, how many times does 4 go into 7? We're going to divide 7 by 4. Okay, if I divide 7 by 4, it goes in there once, and I'm left with a remainder of 3. So that means I to the 7th is the exact same thing as if I do I to the 3rd. Because remember, I get the same thing. I go through 4, and then these were equal to the same thing. So I to the 7th, I to the 3rd. There we go. Here I'm going to have I to the 9th, I to the 10th, 11th, 12th. Okay? So if I can somehow convert all of my i's to be somewhere between 1 and 4, then we can use our I won, and then that'll be easy. For example, if I ask you I to the 21st power, rather than writing these i's all over again, I know that I'm going to keep dividing into groups of 4. So if I do 21 divided by 4, I'm left with 1 left over. So I know that I to the 21st power is the exact same thing as I to the 1st power. And I know that I to the 1st power is just I. Okay? And if I finish the one I did over here, I to the 7th, which would equal to I to the 3rd, that's I, but it's negative. Alright? And that's it. I'm done. Not too